Hello, everybody. Welcome to this edition of the Henstitute. This one's going to be a little bit different. I'm actually talking about some math concepts. We're going to talk about vector multiplication. In other words, what happens if you multiply a vector by blank? And so that's what we're going to deal with. I'm actually using a particular website, and it's kind of a neat one. It's called the Physics Hyper Textbook. So it's basically an online textbook of a variety of physics concepts. So if you're looking for another resource for that, you can go to physics.info, vector multiplication up here, or just physics.info. That'll work. Or just do a Google search for Physics Hyper Textbook. And the reason why I'm picking this one is I found that it had some pretty good stuff. Now, the first part, if you take a scalar and multiply it by a vector, all it does is actually scale the magnitude of the vector. In other words, it makes that vector larger. So, for example, if you had a vector in polar form where you have the radius direction and you have an angle with respect to horizontal, then you could just multiply those by some number. I usually think of vectors as just like north of east or south of west or stuff like that, or the rectangular polar form where you have it as x in the I direction or the x direction and then so much in the y direction. And these, all you do when you multiply by a scalar is you just increase those particular values. So it doesn't change anything about it. So I'm going to jump to a different idea here and see if I can kind of show what I mean by that. So let's say I had a vector that was pointed in this direction. So this was my A vector. And it might be, let's say it's 30 degrees and it's 5 meters long. So the idea is if I took this vector that was 5 meters long at 30 degrees north of east, and I multiplied it by some number, let's say 3, what would happen is then it would just change my number. So it would suddenly be 3 times longer. So it'd have an extra here and an extra here. So it would now be 15 meters long, but it wouldn't change the direction. The direction would still be the same. So it would now be a 15-meter long vector at 30 degrees north of east. So multiplying by a scalar doesn't actually change anything except the magnitude of the vector. So that's the first part. Next part. Let's go back here, scroll down. A thing called the dot product. So what happens if I actually have two vectors that are going to be multiplied together? And what this does is it actually takes one vector and it finds what we call a projection in the direction of the other vector. This little video actually does a great job of explaining this. So I'm going to, and it doesn't say anything, it's just going to show you. So I'm going to go ahead and play this. So you can see here's the B vector, and to find A dot B, what you do is you draw a little dotted line and you find how much one of the vectors is projected in the direction of the other vector. So if you take B and it's dotted into A, it looks like this. So you take B cosine theta times that, or you can project it up here and you take those kind of together. So it's kind of a neat little concept. The cool part about a dot product is you actually get a scalar value. So sometimes this is referred to as a scalar product. And this is the basic definition, that the dot product is the magnitude of each vector times each other and then times the cosine of the angle between them. It's distributive. So in other words, you can distribute it through, if I had a vector times the sum of two vectors. It's commutative, meaning that A dot B is the same as B dot A, which is kind of nice. If you dot a vector with itself, since the angle would be 0 degrees, it's just going to be the magnitude of that vector squared. So it doesn't actually change anything. So therefore, these unit vectors, I don't know how much you've had with unit vectors. We'll talk about them a little bit. But if you dot a unit vector with itself, you just get 1. If you dot a unit vector with another one, so if you try to figure out the projection if two vectors are perpendicular to each other, since the angle between them would be 90 degrees, there is no projection because the cosine of 90 is 0 and you get 0 for all of those. So that's the idea of a dot product. And this is another way to write it. If you've got it in unit vector notation, you just have to multiply them and then add them together. The key thing is you end up with a scalar when you are done. So kind of going back to our original picture here, I'm going to erase this stuff actually. Let's clear the canvas again. So let's say I had two vectors. Whoops. So let's say one vector. Let's just make it a velocity vector. So the velocity was 5 meters per second, and it was just pointed to the east. And then I have another vector. This velocity is 2 meters per second. And just to make it easier, it's 30 degrees north of east. If I wanted to dot these two vectors with each other, so I should probably change them. So let's call this one V1. Let's call this V2. So if I wanted to take V1 and dot it with V2, here's what it would look like. It would equal the magnitude of V1. So we sometimes put absolute values around there to indicate magnitude, times the magnitude of V2, and then times the cosine of the angle between them, which happens to be 30 degrees. And it's always the angle if you put them tail to tail. So it's the angle between them when you're tail to tail. So in this particular case, if I was solving this, it would just be 5 meters per second times 2 meters per second, times the cosine of 30 degrees. The cosine of 30 degrees is the square root of 3 over 2. And then I multiply these, that's 10. So we got 10 times the square root of 3 over 2, so that's going to make that a 5. So this dot product would end up being 5 root 3. And then I could just calculate that out, whatever 5 root 3 is. I don't actually know that off the top of my head. Let's see if I can pull up a calculator real quick. There it is. So if I take 5 root 3, so 3, let's square root it. That's that number, and then multiply by 5. I get 8.66. So this is 8.66 meters squared per second squared. So it's going to be the units multiplied together. So what it's telling me is actually, like it shows, it takes this it projects it in this direction, and then it multiplies this vector times this vector. It doesn't actually have a particular direction, and we're going to find out what this means. What does a dot product mean for us in terms of our physics vectors? But this is kind of the beginning of it. So that's a little bit on multiplying by a scalar and multiplying by what we call a dot product. I'm going to eventually get into the next one, which is a cross product. I'm just going to pause for the moment.